Hey everybody, Shawn here from the Automation Plugin School, and in this episode of the Automation Podcast, I sit down with Adam Gluck, the CEO and founder of Copia Automation, to talk about source control for industrial automation. Adam, thanks for coming on the Automation Podcast. I'm looking forward to learning all about your product. But before you jump into it, could you please tell our audience a little bit about your position in the company?
Yeah. Thanks so much for having us. We're super excited to be here. And actually, as I was kind of jumping into Alan Bradley, way back when, I think I was using some of your videos to learn about it. So it's kind of exciting to circle up and be chatting now. So my background is, so I'm founder CEO. I think, a year ago, if you asked me, I'd feel a little self-conscious about the title, but we've been growing quite a lot. So, we're at around 20 employees. I started the company mostly just, coding in my apartment because I thought that this is something that should exist. And we've seen a lot of growth since then. I before that was a software engineer actually at Uber, where I was focusing on kind of the driver platform. So all of the kind of operational stuff that we do on the developer side to push out code to millions of drivers every month. And then after that, I was working on engineering strategy at Uber. So I was really focused on Uber's overall microservice architecture, developer tools that we're using internally, that sort of thing. And then I jumped ship from the IT world and came to the OT world and have been working on this for a year and a half, 2 years now. So it's definitely been an exciting journey.
That's awesome. What a background.
Yeah, so I'm happy to just jump in if that makes sense.
Yeah, please. Excited to learn about the product.
Yeah, so I think for us, this is focused on source control, Git, and industrial automation, but I'll also talk a little bit about DevOps. And one thing I want to highlight for everyone is, our tool is totally available online. So you can go to copia.io and sign up for a free trial at any point. So if you get bored of listening to me talk, you can always just jump on and test it for yourself. But primarily I'm going to talk about source control Git, and I'll be digging into kind of, why teams are really starting to adopt these sorts of tools as well, and how you justify them internally as well. So, currently we're seeing controls teams are really being crushed. And I think, that's the standard phrase that we hear across the industry. So we see labor shortages, and that's causing increased automation. It's been awesome. Controls engineers are super in demand, and automation engineers are super in demand right now. We've seen post-COVID project backlogs, just overall increase in demand within the supply chain itself. Obviously, you can't go very far without hearing some of the supply chain issues. And because automation engineers are so in demand, it's become really difficult to hire automation engineers, and obviously difficult to retain them, as well as awesome opportunities keep opening up for people in the profession. And so really with that, we've seen people start to move towards tooling in order to do more with less. So if you have, a certain number of engineers, you have to figure out how to make them more efficient. That's where the sort of tool change that we're talking about here kind of fall in. Additionally, manufacturers are increasingly have to find ways to maximize uptime to deliver products faster. So we're seeing, kind of gluts and sudden demand shifts within the supply chain that's causing people to really need to drive uptime for their products. So when you start looking at a product like ours, really it starts to reduce inefficiencies and minimize downtime. And you can see, downtime can be caused by things like PLC failures, routine maintenance. So just needing to modify things on the line, put sensors in place. If you have some, digitization effort, digital transformation, or just, routine maintenance, catastrophic events, cyber attacks, those sorts of things that can cause downtime. And so really, what we're seeing and where Copia came into existence is taking tools that were basically used within, software engineering organizations to drive productivity and uptime, and bringing them to controls engineers, and specifically, tied to how do you bring, DevOps to PLC programming. And really, when you look at DevOps broadly, and I just want to kind of take a step back for a second, you're talking about a bunch of different solutions. The first of which is Git-based source control, and that's really where our solution starts. But you can also move into, once you're reviewing and checking code in, and have all this process around, how you manage your code, you can start to automatically test that code. You can do deployment management. And then, a lot of people with Industry 4.0 have invested in monitoring and SCADA solutions and that sort of thing. There's lots of data pumping, through different software systems at this point. But really, when you look at DevOps and you look at those sorts of best practices, you're talking about monitoring and specifically observability. So basically monitoring what's happening in a manufacturing site. Or industrial sites, you can identify outages and revert back to the last known good version. So that's really the DevOps stack when you look at it, those kind of 4 pillars. And that's kind of the scope of Copia long-term, but short-term, we're really focused on Git-based source control. And it's really these 2 core benefits of driving productivity and uptime.
Now, I'm going to interrupt you, Adam. I think most automation engineers and controls engineers will probably not be familiar with Git-based source control. Can
Yeah.
you, in a sentence, kind of explain what that means?
Yeah, and we'll be digging in like much more deeply
Oh, okay.
within the deck about what Git-based source control is, but
Perfect.
really, ultimately, it's a way of just managing your files. So the typical solution, which we'll go through now, or pretty soon, is like an archive folder. So people will copy paste. File name date is the most common way that people manage files today, and Git-based source control really is letting you keep track of who changed your code, why that code changed, et cetera. So it's really a system for managing code, and then Git itself is a pretty ubiquitous solution that's out there. And so we'll talk about that as well. But Git as a solution has been around for 15 years. Millions of people use it. Microsoft uses it, Amazon uses it, Google, everyone uses this as kind of standard best practice. So just kind of bringing that into the OT space. And modern Git-based source control for PLCs enhances code visibility, traceability, ensuring teams can always identify, access, and implement the last working version of code quickly. So that's back to that why use Git-based source control. It's like, hey, if there's an outage, can you get back to a well-known good version? Git and good source control practices together are really the root of a strong developer tool chain. So part of why we started with this as a technical solution was because it kind of enables the next set of solutions in this space. And we've heard really good responses from teams that have heavily adopted this solution. So we've heard that once teams are really onboarded and do a Git-based source control solution, they're really getting 2 to 3 hours per engineer per week back. This came from a controls engineering manager from a SMB machine builder, so a mid-market machine builder. But one of the crazy things there is like, Git is one of these solutions, and I'll dig into it more. In source control is where there's all these kind of small things that come up in your workflow. So, even if you're developing some code, something broke from the day before, you're like, well, what broke, what changed, keeping track of that. Or when you're in production, maybe someone push code, overnight, you're like, something broke, how can you get back to it, a known good version quickly? And then sharing files and merging and code reviews, you're catching issues sooner before you're having to actually test them on the machine. All of these things end up driving, this sort of productivity to engineers. So it's really a big win for engineering teams. So our goal for this talk is really to get engineers to feel proficient in Git. And so this is, understanding source control. Source control is value add in particular. So understanding what's valuable there, Git terms, workflow, and adoption. And Git has a lot of terminology associated with it. And so we just want to kind of give a high level of some of those terms, give you a little bit of a word soup. And actually within our documentation, we have a glossary of all these terms as well that people can access. And then, industrials and Git in particular. So some of the challenges and why we haven't seen Git adopted within industrials. And that's obviously where Copia comes in, is trying to solve some of those wrinkles, specificity, the operational technology space to make Git work effectively for it. And really, as I said, the goal is to feel proficient in Git. So Git, is used by millions of engineers. The goal is to be able to come out of this talk and be like, hey, I could pick up this tool and start to play around with it. So to your earlier question, what is source control? So before we even talk about what Git is, Git is a form of source control, and there's a lot of source control solutions out there. And we talked about some of these before we jumped on this call. But really, our key thing is that it's not a revolution; it's just common sense. So it replaces a workflow where you use file name and date. And maybe a text file to keep track of your changes, with a system that lets you, mark commits with some context and the information about the person who made the change. And ultimately, and we talked about before, is it improves organizational efficiency and recoverability. So all the benefit reduces to more efficient engineering teams and more uptime for engineers. And as I mentioned earlier, the archive folder is kind of the standard way that people keep track of these files. And we've done talks before. We put surveys in front of them, asking, what percentage of people are using Git, what percentage of people are using SVN, what percentage of people are using an archive folder, and we get consistently, 75 to 80% of people, are using archive folders, and that pretty much aligns with what we come across when we're talking to new companies. And this should look familiar to everyone. You see the date here, you see the name, etc. This is a very standard sort of way that people keep track of their source files right now in industrial automation. However, when we start looking at source control versus the archive folder, version control enables granular snapshots. So you see these tend to be, each day, maybe you copy and paste and rename, and a lot of systems out there operate as pure backup systems. So they're keeping track of that. Within source control, and I'll show this, you can kind of take a granular snapshot that's related to the specific change that you're making. And part of that's because it's actually easier to use source control than it is to go in and copy and paste, then open a new file and continue your work from there. That's a pretty slow process. You can understand who changed your code when and why. So if you look back at that archive folder example, you have the underscore of the name, who knows which Adam it is. If you hire two Adams, like that's a problem. You can start to see the file name, or sorry, the dates there. So you don't know why that changed. Some people keep track of text files. We've seen people even have Excel spreadsheets to manage this. But understanding really like why your code's changing over time and creating meaningful context around those changes is really difficult in a world where you're using purely an archive folder. And then access controls to specific repositories. Oftentimes in the archive folder, you have it as a network drive, or, you have these in emails, or it's on someone's C drive or USB or CD-ROMs. We've even heard people keep track of their files on this. Most good source control systems, give you the ability to define who has access to what file. So it actually kind of gives you that benefit of saying, hey, we have a centralized team that has some reusable code. And then, maybe someone who is at a, plant, they have read-only access to those. So they can know it's running, but they can't change the code or something like that. So defining who has control and having that be well-defined is an aspect of an effective source control system. It enables you to really also start to scale your organization. And then encourages reusable code with a central repository. So, in our solution, most Git-based source control solutions, you have actually a web interface as well. So you can actually keep track and, email people and say, hey, here's the link to the code. But it's all in a centralized place. And then you can bump that change. So if you have reusable, AOIs, or instructions or functions that you have people, or function blocks that you have people using, you can start to make that a reusable kind of code repository that everyone can keep access to, as opposed to a world where code's often scattered, as I mentioned earlier, on C drives and email accounts and that sort of thing. So really, when we talk about source control being common sense, we're really saying, you should understand who changed your code, why. You should be able to control who has access to your files. You should understand the context of all your changes, have granular snapshots. And ultimately, you get this additional benefit of starting to be able to really reuse your code. So those are all the benefits that come with a good source control solution. And as we mentioned, ROI is uptime and efficiency. So you look at operational uptime, the average is $250,000 an hour. Organizational efficiency, hours of work saved. As we mentioned, that one of our customers is saying 2 to 3 hours per week per engineer. Code review, so you catch issues sooner in process. And there's also certain organizations that have really high code review requirements. And one thing we've also seen is traceability. So being able to root cause issues. If something breaks, understand who changed the code so you can fix it. And we've even seen, legal requirements either, from the government or, contractual. So, people will be a supplier to an upstream company, and that company will put in their contract, we need to understand what changed, if something breaks in our product, especially in the automotive industry, we've seen a lot of that. And so, as we start to look for these, productivity improvements too, we start to see, shared code, discovery and template, so really like, the ability to find your code, a merge flow, which we'll talk about, but that's actually one of the biggest benefits of Git in particular, is multiple engineers working on the same file, code review, catch issues earlier, and revision history. So reverting back code. But getting to your earlier question, what's Git? And so, as I mentioned, the previous benefits I talked about, for the most part, were all tied to source control, specifically. So or the broad concept of source control or version control, and why these sorts of systems are good. Why is Git specifically a really good solution? Well, first of all, it's just ubiquitous. So it's made by the inventor of Linux, 15 years old. Everyone uses it. And this is actually important because, it's really just been battle tested compared to a lot of other solutions, like Microsoft, for example, like heavily invests in Git as a project, but also companies like Google and whatnot, also like put engineering resources towards it. So you start to see with a Git solution that you really have an ecosystem of companies that are supporting it with really high quality engineering behind it. And the other benefit of that with using something like Git is you start to get the additional set of solutions. So for example, people came to us and we're talking about our solution. They were looking for certain integrations integrations with particular vendors, and they already had a Git level integration, for those vendors. So you also get the benefit of the ecosystem of solutions around Git because it's so ubiquitous. The other thing that I think is interesting for a Git-based solution is that it's distributed and works offline. And this is actually often touted as a really big benefit to Git. And when I think about the industrial world and people, commissioning, being at a manufacturing site, needing to, be offline or having limited internet connection and maybe going back to a hotel at night, and we often hear is when people save their code or at the end of the week, the fact that you can store all your changes and don't need a persistent connection to a server is super, super important. And then the other thing that's related to that offline benefit is there's this concept in Git, which we'll dig into more of branching and merging rather than locking. So if you look at Subversion or a lot of check in and out systems, you often have to say, hey, I'm going to lock my file, and then I'm going to go ahead and I'm going to lock my file, and then I'm going to go ahead and make changes. Then I'll unlock it and someone else can make changes. Well, what Git enables is to be able to say, hey, I'm going to make changes on this file and I'll stitch it together later with other people making changes to the same file. So it unlocks workflows where you can put multiple engineers on the same project at the same time. So this is really kind of the unique benefits of Git over other, source control systems, and why it's become really ubiquitous in this space. And then at Copia, what we've done is we've just standardized around Git. So the underlying infrastructure for everything we do is very standard Git. And then we built a layer of support for industrials, which I'll kind of demonstrate later. So that's really what Git is. And I keep harping on this point, but it's because it comes up a lot, which is, people be like, well, hey, this is a whole new system. Can I train my team on it? How hard is it to learn? And millions of people use Git for their daily workflows. So it's not something that, some engineers use at some, tech companies or whatever. It's really just become ubiquitous. And so it's very learnable. We know people can learn it. And the thing I always say is practice is simpler than theory. So if you go online and you read the Git documentation, it can feel very headachy because they kind of leak out a lot of internal implementation there. But the goal of this talk and what I'm going to dig into is really like how simple it is to actually just do the workflow and really think about clicks. And one of the things that came up for us when we started this is we talked to someone who, came to us and he's like, well, hey, I always copy and paste. It's pretty simple. Feels like you're putting some additional process in. I don't know why I would do this. And we call that kind of the +1 step problem. And so I talked to this person and came back to them, 3 weeks later. And I said, hey, this is how I think we're going to solve this. It's just a button that you press that says commit. And then you've saved your changes. And he's like, that's great. So really focusing in on Git as a workflow that's super straightforward and actually easier than existing workflows once you get into it. And that person eventually became a really big advocate of our product. So we've really invested in not only supporting Git, but also making sure that it's easy to use. So kind of to hit on some of those keywords though, and focus first on like some very light theory is that word distributed. All distributed means in this context is that you have a remote repository. So that's a repository that's really living on a remote server. So it's on a server somewhere, either self-hosted or in the cloud. And then what you see is those local 1, local 2, local 3, those would be all your machines. So those would be people who are just coding on your team. And really the very, very basic workflow of this is that you pull code from the remote. So you're just getting the code off the main machine. And when you're done, you push to remote. So that means you're pushing your set of meaningful changes so that everyone else can pull that context. That's all distributed means. But that also shows the benefit of, those local offline changes and that push pull there.
Now I'm gonna jump in here. Excuse me. I'm sorry. So let me ask a question here. I can definitely see two types of users. There's one user where they have multiple offices located around the country, around the world, and they'll want to have an online repository. So any of their engineers can grab, say, the code for machine number 5 and tweak it and then share it with the rest of the company. But I can also see instances where a company has one very large location, everything's very top secret. They want the repository self-hosted in their own building and never touch the internet. From what you're saying, this supports both those type of scenarios.
Yep, 100%. So if they want to have it self-hosted on a local network, or we often see people using virtual private clouds now, so they'll have their kind of own cloud partition. They can do that super, super easily. And then, otherwise would be, the example you gave of someone who's very distributed and wants to put in the cloud or use our solution. So all of that's doable. Yeah.
Excellent. Thank you.
Yeah, remote in this world is just really a Git server. It's just, something, a server sitting there that's, managing your files for you, ultimately. So this is kind of the distributed workflow. And then, one of the things that's really related to this is branching and merging. So you see this like pulling and pushing, but you're like, hey, what if two people work on the same file? What's going on here? And so what ends up happening is you have this main branch. So you can see that there. That's kind of the main code. That's the source of truth. But what Git also supports is the ability to say, hey, I'm going to make a branch. So you see this new branch at the top, those yellow circles. I'm going to make a new branch, and this branch is now it maintains the history of all the changes, and I'm going to make my changes there, right? So basically you have your own safe scratch place. And then you can merge that back into main when you're done. So the one like simple workflow, which we'll go through, is just, you're just pushing code to main as you're done with it. But as teams get more advanced, what they can also start to do is like build these branches where they write their own code locally, and then they merge it later. And then all merging really is taking the history from your branch and putting it into the main set of commit histories. Or, if two people are working on the same file, stitching the code together. So if you're working on two different routines, you can stitch the code together and make sure that, ultimately, you have a finished project that multiple people contribute to, and you're not, stepping on each other's toes by either overwriting files or having to lock files and lock people out of it. So that's really branching and merging. So, you hear the theory of Git, which is like, the distribute it, offline, and then you hear branching and merging, and you're like, oh, there's a lot there. But really all branching and merging is having some scratch space to make your changes, and then you stitch your code in later. And then all distributed is you're pulling code locally, and then you're pushing it later. So it's pretty straightforward, and then we'll go through the granular steps. But the other thing I want to talk about too, as we're kind of getting deeper into what Git is that it's actually very easy to migrate to Git. So Git exists at the file system. So we'll often have people saying like, well, how do you integrate into Studio 5000, or how do you integrate into TIA Portal, V17 or whatever? And oftentimes, what we'll say is like, we have support for it. We don't integrate directly into the environment. Actually, Git exists at the file system layer. So if you had an archive folder, you can just turn that into a Git folder. And all Git does is add kind of a local private directory that marks it as a Git folder. And then suddenly you're onboarded into Git. So folder becomes a repository. So that's another one of those like Git keywords, but it really just is like a folder. You hear people say repository, and everything is just organic on the file system. And so migrating can be, as simple as a copy and paste if you just want to take one file out of your archive folder, or turning your archive folder existing code into a Git repository. And we see people adopt in 10 minutes. So we'll talk to people and onboard them into the product. And it's basically like, hey, sign up, download the desktop app, take your current project, put it in the folder, and then Git starts to track all of the changes that happen on that file. And then you can just kind of commit those changes, which I'll go through in a second, but it's very easy to migrate. And this kind of shows an example of this. This is in one of our first videos that we put out for showing what a Git-based workflow is. And it's really, just simply dragging the existing files to your local Git repository. And you can see here, the folder on the left has that like .git subfolder, and really that's just what's marking it as a Git repository, and Git manages that all for you. And if you use a product like ours, you wouldn't even think about that. So it's really very, very straightforward to adopt. And I always like to say like the cost of R&D is a lot higher is a lot lower than the cost of migration. So we don't want anyone to have to like shut down a line, and we know people are super busy. So we try to build a solution, and part of why we start with Git as a solution, we think about DevOps broadly for the space, that's super, super, super easy for teams to adopt and start using. And so now we'll go through the standard workflow in Git, and I'm using Allen Bradley as kind of the base example here. Our solution right now supports, Allen Bradley, Siemens, Code Assist, and we have some very limited backoff support. But I'll use kind of Studio 5000, since I think that's the more standard thing that a lot of people come across in North America. But you can see here really the first step in a Git workflow is you open a file in that repository folder. So in this case, it'd be that right to left.acd. As you would usually in Studio 5000, then you'd leave, if we're going to talk about our product, the desktop app in the background, you visually confirm the changes. And this is actually where, if you talk about even individuals who use the product, some benefit of it is you can actually see the differential of your code as you're changing it. You commit those changes. So you add some context and press the commit button to store a snapshot of your code locally. And committing versus pushing is just local snapshots. So that's back to where I was talking about earlier. Typical with an archive folder is you back up your code. What we have people do is we just have them kind of commit those changes locally over time, and it just immediately saves that version history without having to copy and paste the file or do anything like that. It automatically handles that all for you. It picks up on the change and then manages it for you under the hood, and then push those changes. The committing changes is local, so you could be on a site for a whole week with no network connection and then push all your changes later and keep track of that whole history. So it's really powerful in those environments to have that kind of differentiation there. There are Git providers that aren't Copia. So, GitHub has a Git provider, GitLab does, Git Kraken. Some of these are really useful. The reason that we build out our solution is, all of those assume text-based files. And most PLC programmers program in ladder logic or function block diagram, or even structured text is often embedded, in binary files and XML files, and they just don't work super well with those other solutions. So Copia kind of enables, a ergonomic Git-based solution that makes sense for people who are used to visual programming paradigms. And so with that, let's walk through an example of a standard workflow with Copia as the basic desktop app. And this is just to rehash this point. So first of all, you change code. And as I said, Git integrates to the file system layer. So it's really just opening a folder where the file exists and making a change to it. You don't need to do anything else. And then Git immediately picks up on those changes. So this is kind of the confirm changes and commit changes. You can see here visually in the background, this kind of like red change that was picked up on. And then you can see, you can add a message there. So removes a rung that we're no longer using, some basic message, and then you commit that code locally. So really that's, you visually see the change and then you commit the change locally. That's kind of the big thing there. And then from there, you push that change. So you push it to remote. And that's it. That's the whole Git workflow and it works for 80% of people. So you get all this theory about, Git branching, merging, et cetera. People are like, this is, crazy next generation stuff. And it's like, well, really, you're opening a file, you're confirming your changes, you're adding a message to it, and you're committing that change and just pushing it to the remote server when you're ready. And that's the whole thing. And that works for 80% of use cases. The other one that we like to talk about, and most people actually just organically pick this up once they've been using the standard workflow. And the way I actually personally adopt tools is that I always don't really buy into the marketing very much. So it's like, I'll just do the most basic thing. And then eventually, when I hit a snag, I start to do the next thing. And I think that's what we see organizations often start to do is, they'll start to have multiple people using the tool and they'll start to dig into some of these solutions pretty organically over time. And really, the only difference is, you do the same workflow of those committing local changes and then pushing, but you do that, with a branch first. And then from there, you dig into, the standard workflow that you do there. And then it also opens up the ability to do code review and merging, which I'll show. So when you look at branching, really in a desktop solution like ours, the whole creating that branch, once again, we had all the dots and all that stuff there before is just pressing this button, new branch. And that creates a new branch and a new scratch space, and you can start committing your changes there. And so, you look at a standard workflow here, you're really just pressing commit to add a rung as opposed to commit to main or commit to master. And you can see here, once again, this picks up on the change. So you didn't have to copy, paste, rename. You see the green there, and then you commit to that add a rung branch now, as opposed to the main branch. And then from there, you have your coworkers review your code. And this isn't something that's necessarily tied to all Git solutions. This is something that exists in Copia and, products like GitHub and GitLab, but you can do kind of code reviews. You can actually have a record of the changes that are there in that branch. And someone can come in and actually approve that change and say, hey, let's go ahead and let this, into the main branch. So you actually can build that process into your organization. And when you see that files change tab here, you can actually see visually the changes. And then once you commit those changes, you can actually have a record of that history, which a lot of organizations actually require from an auditing perspective. And then finally you merge. And, once again, merging, we looked at all those dots, all the different ways, branches, et cetera. Merging ultimately reduces just pressing a button, which would be merging this pull request. And there's some additional nuance there as we start to look at stitching codes together and if there's conflicts and that sort of thing. But the power that you unlock with that code review merging is like suddenly you can throw 5 engineers on the same project if you need to get it to market in a week, because everyone can work on different routines and everyone can review their code and make sure that they're kind of aligning together. So this is where you start to see a force multiplier productivity for teams as they move from that basic, hey, let's just keep track of the version history, to the more advanced, hey, let's review code and let's merge it. But you get a lot of benefit just from that basic flow. And we've seen people just, adopt this solution more and more over time and move towards these advanced solutions pretty much organically once they're in the tool. And then once you do all this, and this you get with just the basic workflow, you can always access the commit history. So you see here, the history there, update right to left L5X, and you're really seeing, what happened in that change. And so in one place you get to see, hey, Adam Gluck changed the code 5 hours ago. This is the context of that change. And you can see the differential there. So it gives you the entire history and entire understanding of what happened within your projects, right there in the product itself. And that becomes really powerful for debugging, but also, increases the speed of development, because, if some other person pushed some code the day before, suddenly something that was working is broken, you can be like, well, what the heck changed here, And then finally, if there is a downtime incident, it's easy to go back to the previous versions because the entire history is there. I went to this great talk actually by a Netflix SRE, and I always say, like, Netflix never goes down, and they're streaming so many gigabytes of terabytes, petabytes, whatever of data all the time. And one of the things that they really do is they say, anytime a human has to look at a problem, it really slows things down a lot. So the speed at which people can kind of quickly go back to a previous version, revert to previous, and then kind of push it out, the faster off you are. And so, this kind of enables that workflow where you say, hey, this person pushed this code yesterday, the thing that their code touch broke, let's just revert their change, and then we'll push this into production. And so ultimately, as we talk about, these workflows really drive productivity. Code review becomes streamlined, code is easy to share and reuse, regressions resolve faster, and overall, it just reduces a lot of manual process. And so when you look at controls engineers working, 60, 70 hours a week, we talked to someone recently who said his friend, worked 27 days in a row. So you're looking at that sort of strain on organization, giving people those like 2 to 3 hours a week back, or even more if you're working more hours, obviously, and reducing the amount of manual process can really be a big time saver for organizations. And then ultimately, we've seen historically, and people might ask, like, why haven't industrials already adopted Git? And I think there's kind of this like false narrative of like, oh, well, there's resistance to it, and all this stuff was really just didn't work super well for industrials. So, there's the industrial file types that were primarily binary file types, for a long time. And only recently, you have Siemens with an openness API. You have Rockwell with the L5X file format. And, by 2018, they said basically Studio 5000 is their standard software now that people use. You have, Code Assist, where you can export as XML. You have the Open XML format. Backoff is all XML. You look at BNR, that's all text-based as well now. So really, industrial file types have opened up to enable this sort of solution, and we can take those text files and do visual code representation. So we can start to render the ladder logic. And then, all of these files are slightly different. So they're all vendor specific. So really, if you just use Git raw, it doesn't work super well. But once you start looking for industrials, because of all this nuance, but once you get really deep into it and you build out this solution set, it becomes a powerful solution again for the space. So we really view ourselves as taking this great solution in the IT space and making it work really ergonomically for the OT space. And as I mentioned, primarily our solution is Git at the root of it. It's really just a standard Git server, but we provide that additional layer of industrial file types and rendering of visual programs and differentials and custom merge flows and all that stuff. So finally, we say, why adopt Git? It's common sense, not a revolution. You should understand the context of your changes. You should be able to access your files when you need them. You should have access controls for them. You should be able to go back to files, that were the last known good version. All of that stuff, I think, is increasingly becoming table stakes, especially as people are operating, multi-million-dollar lines. easy to adopt. It is not a big investment from an adoption perspective compared to like, migrating a whole line or implementing a new SCADA system or a new HMI system. All of that takes a lot of work. Git is, you download it and you drop your file that you're working on in it. It's super easy to adopt and gives a lot of benefit. It's ubiquitous and popular. I think this is also important as people look towards, retraining controls engineers. If you're an engineering manager, giving people solutions that they've heard about, and a lot of people in the space have also heard about this solution or that is exciting and new, is important. But also it's important because, the ecosystem and just the really strong support from top tier tech companies, globally for this solution. And then ultimately, and I always come back to these two benefits, it drives uptime and recoverability. And that's ultimately what drives the ROI that makes it pretty much a no-brainer, especially at the price point of a lot of these solutions, including ours. And so, I said, what if your team could adopt a tool in 10 minutes that grants each engineer 10 hours every month? And then finally, the last thing I'll talk about, is coming back to this DevOps stack. Git is the root of all DevOps. So CI/CD, and really the vision, when I pitch Copia, is DevOps for operational technology. And so once you have Git-based source control and you're managing those files, in this kind of effective way, and you have code review and all of that, then you come into, automated testing. You can automatically, if you have simulators set up, you can run those, or, solutions like Backoff and BNR actually have automated test suites that you can run code assist as well, that you can run to do kind of logic tests on your code. So you can kind of start to put some of that testing, or, even tools that, enable you to do static analysis, Backoff support stuff like this, that enables you to really make sure that your code doesn't have issues kind of from an automated testing perspective. Deployment management. So once you have those files, you can invest in actually deploying your code to PLCs through a deployment management system. So we see people who have systems that, they can commit their code and then deploy, immediately into production, or kind of queue up changes as well. So it creates kind of a remote deployment model. And then auto backup as well becomes more powerful in the space. And then finally, observability and monitoring. Once you deploy your changes, you want to know if something breaks. So if you have those systems in place, you can be like, hey, something broke at 8 p.m. and we saw a code change at 7:30 p.m. This is the issue. Actually, someone brought up this might be a problem in code review. Let's revert the change and fix it and roll it out. And then you have a system that really lets you confidently develop your code and deploy it. And then ultimately, reduces downtime and up levels operational efficiency. And so that's the solution. As I mentioned, if people want to try it, you can just go on our website and sign up for a free trial. So, you don't need to talk to a salesperson, but obviously we have, customer success and salespeople as well. If you want to like figure out how to adopt this solution for your team, but, you could literally go today to copia.io, press free trial and sign up and just get going on it. And we have a 2-week trial. And as part of that, you can add as many people as you want. And then going forward as well, if you have, some people that write code and some people that make changes, we support, unlimited read seats. So people can really just be added to the files and get access to them pretty easily. So that's everything on my end. I know I just talked a lot. So do you have any questions?
No, I appreciate you coming on the podcast. I think most of us, or many of us, are familiar with the legacy source control options that are available for industrial control systems. And I think this definitely gives those users a new option that doesn't require buying a very, very expensive software package and owning a server that they have to maintain. It gives them a user-based pricing, if I understand you correctly,
Yeah.
where they can only subscribe to as much as what they need.
Yeah.
Only subscribe to as much as they need, and they don't have to make this initial, capital investment in a expensive server and an expensive software suite just to get started, which is for the classic source control and disaster recovery systems can be a very large, can be a stopping point in moving forward with the project. So having said that, it's great that there's another option here, and I'm really excited to learn more about your product. So Adam, thank you very much for coming on the Automation Podcast.
Yeah, thank you so much. Really, really appreciate you having us on here. It was super fun to talk about this. So we appreciate it.
Well, I hope you enjoyed that episode, and I want to thank Adam for taking all that time out of his busy schedule to come on the show and bring us up to speed on his source control solution for industrial automation products. With that said, if you're watching the video edition of this episode, please consider giving us a like and a sub. And if you're listening to the audio-only edition, please consider giving us a 5-star review, because that really helps us find a wider audience and find new vendors to come on the show. You can also follow me and get in touch with me over at automation.locals.com, and you'll find all of my training courses over at theautomationschool.com. With that said, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.